Let's check out a few more examples for our non-standard z-scores and percentages. So example 5, suppose that the distribution of monthly earnings for all people who possess a bachelor's degree is known to be normally distributed with a mean of $2,166 and a standard deviation of $455. What percentage of people with a bachelor's degree can earn or may earn less than $1,661 per month? So this is like the first set of problems. We are not being given a percentile. We are being asked to figure out what is our percent difference. So looking at our calculator, and again, I've changed my view a little bit so we can see things a little easier. We do not need the inverse CDF. So I'm going to go ahead and delete that out. And it pops up with the options we were using before. We need to make sure we type in our mean, which in this case was 2166, and then our standard deviation was 455. Okay, so first problem was what percentage of people with a bachelor's degree can earn less than 1661 per month? So again, making sure that you have that find cumulative property checked off. What do we have to put in for our minimum or our maximum? Well, if we're going less than 1661, that needs to go in as our maximum value. So 1661, and then it spits out our value. And again, if we want to see what this looks like, hit the little plus sign and it will zoom in to show you the shading on the graph. We are looking at everything that's below that line. And again, lower than halfway. So it makes sense with the percentage we got out, 0.1335. That's really 13.35%. So definitely less than half. So let's type that in. So that is, or write that in. So that's 13.35%. Alrighty, next one. What percentage, same situation, earn more than 1206? So again, all we need to do, change up your minimum and maximums. So more than 1206 means that needs to go in as the minimum, but the maximum, I'm just going to delete that out and use the default value. Again, as soon as I click anywhere else, it pulls that default of positive or negative infinity in. So we get 0.9825, which if I round that to one more place, I'm looking at 98.26%. Again, my apologies. I got the keyboard hooked up to my computer, so that's why I'm trying to write on a vertical screen. Doesn't always work well. Okay, part C, same situation, but they're giving us both the minimum and maximum. So again, we just type those in. Okay, so minimum is 3016. Maximum is 3481. So there's, whoops, I turned it off. So again, not too many. If I convert that over to a percentage, again, move your decimal place over 2 spots. So we're only looking at 2.89%. And again, you'll notice it only shades in very small amount over towards the left. And in fact, if I zoom in a little bit on that, you'll notice it does cut it off at that higher value, but it is still just a very small portion of the graph. Alrighty, next situation. The time it takes to complete an obstacle course is normally distributed with a mean of 12 minutes and a standard deviation of 3. So let's just start typing that in. So right off the bat, I have to change my values. So mean is 12, comma, standard deviation is 3. So there's my situation. Notice I didn't change my values for my minimum or maximum, so it's displaying a 0 because it doesn't really make sense with the situation yet. So here we go. A prize is going to be awarded to the fastest 5% of people that complete the course. So what is the slowest time a person could complete a course and still get a prize? So this is one they're saying top 5% is really which percentile? Well, fastest 5% means what percent is going to be below? 95. So we're really looking for the 95th percentile. So that means I can't just do normal distribution. I need to add the extra at the end. So that's dot inverse CDF. And again, as soon as you finish typing it, it should stop being in italics. It's recognizing that function. And again, 95th percentile, type it in as a decimal, 0.95. and it spits out the number. That number is your answer. We don't have to convert it all. So 16.93 is our lowest time. We don't have to round, so 16.93 minutes. There's our answer. Alrighty, example 7. The heights of a group of 500 10-year-old boys are normally distributed with a mean of 55.9 inches and a standard deviation of 5.7. What height would correspond to the 75th percentile? So again, we need to use inverse CDF, but we need to change our info about the distribution. So average is 55.9. Standard deviation, 5.7. And percentile, if we're looking for 75th, decimal is 0.75. So that means the height that corresponds to the 75th percentile is 59. Oops. 59.74 inches tall. Alrighty, as always, let me know if you have any questions, need to take a look at any of these questions or see how to set them up using an alternate resource. But I would suggest using Desmos. That's going to be your most straightforward way into these problems. Let me know if you have questions.